Welcome to the unit on algebraic expressions, the laws of indices. The objectives for this session are to understand the laws of indices and apply these laws to algebraic expressions to simplify them. We begin with some notation. Here's x raised to the power y. In this example, x is called the base, and y is known as the index, power, or exponent. Laws of indices can be used to simplify powers of the same base. So a to the m times a to the n is equal to a to the power m plus n, and similarly for the other three laws. Let's have a look at an example. Simplify 3 to the power 5 times 3 to the power 6. Since we are multiplying two numbers with indices, we will be using the law highlighted on the screen. And since we are using the same base, we must add the indices, as shown. So we have 3 raised to the power 5 multiplied by 3 raised to the power 6 equals 3 raised to the power 11. Let's take a look at another example. Simplify 4 to the power 8 divided by 4 to the power 3. Since we are dividing two numbers with indices, we will be using the law highlighted on the screen. And again, since we are using the same base, we must subtract the indices, as shown. So we have 4 raised to the power 8 divided by 4 raised to the power 3 equals 4 raised to the power 5. And let's have a look at another example. Simplify 5 to the power 2 raised to the power 3. For this example, we use the law highlighted. We now multiply the powers as shown to give us 5 raised to the power 6. Now let's have a go at this example. xy all raised to the power 5. So using the highlighted law gives us xy all raised to the power 5 is equal to x to the power 5 times y to the power 5. Now let's have a go at another set of examples which are a bit more involved. We will first consider the solution to example 1a. As all the numbers and letters are multiplied by one another and order does not matter in multiplication, we can separate the numbers on one side and letters on the other, as shown. Simplifying 3 times 4 gives us 12. We will now use the first highlighted law to help us solve a cubed times a to the 4. So adding the indices gives us a to the power 7. And overall we have 12a to the power 7. We now simplify example 1b. We have the numerator and the denominator. We can cancel, so 25 divided by 5 gives us 5. And using the second law, we can subtract the indices as shown. To give us 5b cubed. And now for example 1c. Using the third law, we multiply the indices as shown to give us c to the power 8. Rearrange so that the figures are all at the front of the equation. In this case, this is only 3. Now use the highlighted law to simplify the rest of the equation to give us 3c to the power 11. We now attempt example 1d. Solve the first part of the equation using the law highlighted. So 5d cubed all raised to the power 4 equals 5 to the power 4 times d cubed to the power 4. Now using the third law, we have d cubed raised to the power 4 equals d to the power 12, as shown. And now using this highlighted law, we subtract the indices to obtain d to the 9, which gives us 625 times d to the power 9. As shown. Now let's have a look at some more involved examples. We are required to expand and simplify the expressions shown. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. We begin with example 2a. Expanding gives us the expression shown. So minus 5x times 8x and minus 5x times minus 2. Simplifying to minus 40x squared plus 10x. Now let's solve example 2b. Expanding gives us the expression shown. And tidying up, and now applying the first law of indices. So we add the 3 and the 4 as shown to give us 7, to give us 2y cubed minus 3y to the power 7. Now let's solve example 2c. So expanding, and then tidying up, and now applying the first law of indices to add the indices as shown, and for the second term, and for the final term. Now present the equation in descending powers of x. So x to the 4, x cubed, x squared. We now solve example 2d. So expand the first term and the second term. And now for the second term, as shown. And tidying up, and finally tidying up some more. So 8x minus 6x is equal to 2x. And here's our expression. Now let's practice some simplifications. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. So let's solve example 3a. First divide each term in the numerator by the denominator. X cubed divided by x squared, and x to the 5 divided by x squared. And then using the second law of indices, subtract the indices here, 3 minus 2, and here, 5 minus 2. And then tidying up, gives us x plus x cubed, as shown. And now for example 3b. Again, divide each term in the numerator by the denominator. And then using the second law of indices, 2 minus 1 here, and 7 minus 1 here. And tidying up some more, gives us 5/3 x plus 2x to the 6. And finally, for example 3c. Again, divide each term in the numerator by the denominator, as shown. And using the second law, 8 minus 2 and 3 minus 2. We have x to the 6 here and x here, which gives us 4x to the 6 plus 3x, as shown. This brings us to the end of this session. If you have understood the content of this session, you should be able to understand the laws of indices and apply these laws to algebraic expressions to simplify them. Thank you very much for listening. For a deeper understanding, please do attempt the exercises in your textbook related to this topic.